Hello, Matt here from chemistrystudent.com. In this video, we're going to look at atom economies of reactions and how to calculate them. We're going to talk about what percentage atom economy is and how to calculate it using given data. In most reactions in chemistry, more than one product gets formed. Usually, however, only one of the products formed is the desired product, the thing that we really want to produce. The other products are considered byproducts that we aren't really interested in. This means some of the atoms in the reactants don't end up in the desired product. For example, we can form zinc in the reaction between zinc oxide and carbon. Carbon monoxide is also produced, however. This means the carbon and oxygen atoms in the reactants don't end up in the desired product, zinc. A reaction's atom economy is a way of describing what proportion of the reactants end up in the desired product. We do this by comparing the total relative molecular masses of all reactants to the relative molecular mass of the desired product. The atom economy of a reaction equals the total MR of the desired product divided by the total MR of all reactants. You may also see this written as total MR of the desired product divided by the total MR of all products. This means the exact same thing. Total MR of all reactants will be the same as the total MR of all products, due to the conservation of mass. All the atoms present in the reactants at the start have to be also present in all the products. Atoms don't get made or destroyed during chemical reactions. For example, with the zinc reaction just mentioned, the atom economy would be the MR of zinc, in this case just its relative atomic mass as it's an element, divided by the MR of zinc oxide, add carbon. The relative atomic mass of zinc is 65.4, oxygen 16 and carbon 12. This gives 65.4 divided by 65.4 add 16, add 12, 0.7. We usually express atom economies as percentages. To do this, we multiply the decimal by 100, in this case 70%. This percentage atom economy tells us that out of all of the reactants matter at the start, 70% of it ends up in the desired product. Or in other words, for 100 grams of reactants reacting, 70 grams of desired product gets formed. An atom economy of 100% means all reactant atoms end up in the desired product. This can only happen where there is one product formed in the reaction. For example, when calcium carbonate is formed from calcium oxide and carbon dioxide, the percentage atom economy must be 100% as there is only one product formed in the reaction. The MR of calcium carbonate is 40.1 plus 12, plus 3 times 16, 100.1. The MR of calcium oxide is 40.1 plus 16, 56.1. And carbon dioxide is 12 plus 2 times 16, 44. The percentage atom economy for this reaction would equal the MR of calcium carbonate, the desired product and only product, divided by the MR of calcium oxide, add the MR of carbon dioxide. 100.1 divided by 100.1 equals 1 times 100, 100%. The lower the atom economy of a reaction, the lower the proportion of reactants that end up in the desired product. To make help processes as sustainable and green as possible, reactions with high atom economies are desired, as this means less wastage. When dealing with percentage atom economies, it is important to pay attention to the ratios of products and reactants. In the formula used, the total MR of the desired product includes the molar ratio of the product formed. For example, iron can be formed in the reaction between iron-free oxide and carbon, forming carbon dioxide as a product as well. The balanced equation for this reaction is 2Fe2O3 plus 3C forms 4Fe plus 3CO2. To find the percentage atom economy, we need to divide the MR of the desired product by the total MR of all the reactants. The 4 in front of the Fe tells us that 4 moles of Fe are formed in the reaction, meaning we have to multiply the relative mass of this product by 4. In this case, 4 times 55.8. The 2 in front of the Fe2O3 means we also have to multiply the relative molecular mass of Fe2O3, 159.7, by 2. Equally, the 3 in front of the C means we have to multiply the relative mass of carbon, 12, by 3. This gives percentage atom economy equals 4 times 55.8 divided by 2 times 159.7 add 3 times 12, all times 100, 62.8%. The final thing to point out is that percentage atom economies are theoretical values. Unlike percentage yields, atom economies aren't experimental, they are only based on the balanced equation for a reaction. As a result, the percentage atom economy for a given reaction will never change, regardless of how you carry out the reaction or the amounts of substance you use. So, to summarize, atom economy is a way of describing the proportion of reactants that end up in the desired product for a given reaction, based on mass. By comparing the total relative molecular mass of all reactants to the relative molecular mass of the desired product formed, we can determine how much of the reactants end up in the desired product. Atom economy equals total MR of desired product divided by total MR of all reactants. To give atom economies as a percentage, they are times by 100. An atom economy of 100% means all reactant atoms end up in the desired product. This can only happen when only one product is formed in a reaction. The lower the atom economy of a reaction, the lower the proportion of reactants that end up in the desired product. To help make processes as sustainable and as green as possible, reactions with high atom economies are desired, as this means less wastage of reactants per mole of product formed. Atom economies are theoretical and are based only on the balanced equation for a reaction. They aren't based on experimental data. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.